Hello everybody and welcome to this first official video of our pre-calculus course. I'm glad to see you here. I'd rather see you in person, but if you see this video, it's because I can't see you in person. Not my choice. Not my first choice, but at least we are here. We are here to begin this course with probably the most fundamental part of pre-calculus, which is the study of the rules of exponents. So the rules of exponents are really basic to algebra, just like algebra is really basic to calculus. So if we master those rules of exponents, there's quite a few, but we're going to practice those like all week. If we master this, we're going to be in excellent posture for the rest of this course. So without any further ado, vamos! All right. So, rules of exponents, mesdames et messieurs. There's a couple. What do I got? I got 11 of these. So let's start with the first one. La première. If you see x to the a times x to the b, notice that it's the same base. X is called the base, and a and b are both called the exponent. Of course, you know that. So if you have x to the a times x to the b, you are allowed, should you want to, you don't have to, only if you want, you can write this as x to the a plus b. Little quick example here to illustrate, nothing too fancy. So suppose I have to multiply x to the 1/2 with x to the 3. How would I do this? Well, I got the same x, right, in both places. So that means I can add my exponents. Very fundamental. So 1/2 plus 3, that would be 7/2. First rule. If there is a rule for multiplication, you've guessed it, there is a rule for division. X to the a divided by x to the b. That a looks really bad. Looks like it actually caught COVID or something. So x to the a over x to the b. I do not need a bracket here. What is this? Well, you know this one as well. If there's a division, instead of adding the exponents, we subtract them. So that's the same x here. You gotta have the same x. If it's not the same base, then this rule does not apply. So quick example. Suppose you have x to the 2 divided by x to the 7. Then you can actually do x to the 2 minus 7. And of course that is x to the minus 5. And that's that. Here's another rule. X to the a. This time I do need a bracket because I'm going to raise this whole shebang to the power of b. X to the a all to the b. You know this one? What is this one? What do you think? Say it out loud. Yes, I heard you. You're right. That's exactly it. This is x to the a times b. Petit exemple, what shall I have here for you? X to the 4 to the power of 3/2. Notice 1x, not 2, like in the previous rules, only 1x. And that means that I have a power raised to a power. I multiply them. That is x to the 4 times 3/2. That x to the what? 12/2. And of course that's x to the 6. Bien sûr. Fourth rule. Oh yeah, those negative exponents, we're going to meet them plenty, both in calculus and in pre-cal. I don't really need a bracket there, but I've put one there, so I'll keep it. X to the minus a negative exponent. We've met this often in high school. If you have a negative exponent like this, you can write it as x to the positive a. So here's an example. How would I actually write x to the minus 5? What's another way of writing x to the minus 5? Well, x goes down, and it's 1 over the same x. But notice how minus a became plus a, so how minus 5 is going to become plus 5. Yes, ma'am. Yes, sir. C'est comme ça, la vie. Number 5. I can write my good old x to the a. Again, I don't need a bracket there, but I'll put one anyway. More brackets is better than less brackets. You know that. Do you know that? You should know that. More brackets is better than less brackets. So x to the a, look at what happened here. I had a negative exponent and I brought it down and it became positive. That's the reverse rule. That is the same thing as x over 1 over x to the minus a. It's like if you're going to trade places, if the up is going to go down, then simply the sign of the exponent is going to change. The a positive, when you bring it down, becomes an a negative. Example. You could totally write x to the 2/3 as 1 over x to the what? Yeah, you bring this guy down, it changes its sign. Minus 2/3. All right, these are pretty basic. So we'll erase this now since I have not a lot of space, as you can see. And we'll move on to rule number 6. So, rule number 6. I told you there were like 11 of these, so we'll need another whiteboard, pretty full. And then we'll do some examples. We'll do some problems. Okay, numéro 6. The sixth rule, x to the a over b. Once again, this a is a little bit on the dark side. It went to the dark side. Let us bring it back to the light side. X to the a over b. This time, one base, x, and the exponent is a fraction. That's a tricky one. That's a tricky one. This is the bth root. Here's a root. X to the a. Roots are nothing else than disguised exponents. Right? So x to the a over b is the same thing as the x to the a, the bth root of that. This is true when x is positive, right? So if x is negative, all sorts of bad things happen. We will not consider these cases at all. So what's a quick example of this? What's a quick example of this? Well, you can have, for example, x to the, I don't know, 5 over 4. What's another way of writing x to the 5 over 4? Well, notice that the denominator of the fraction, the b, becomes the type of root that we have. So my denominator is 4. That's going to become the type of root that I have. So x to the 5 over 4 is the fifth root of what? I'm sorry, the fourth root of what? X to the 5, x to the 5. So this is something we will use quite often in this course, and also in calculus, plenty full. All right, so what now if I have two variables? Oh, but before that, this little guy here, before we go to x and y, this little guy, which is kind of a ground rule, anything to the power of 0. Remember that from high school? Anything to the power of 0 is 1. So if I were to give you like an example of this, I would say, I don't know, 2xy 3 to the power of 0. What is that? It's to the power of 0, and anything to the power of 0 is uno. All right, now down to those rules that actually have xy in it. So x times y, so two variables here multiplied together, the times in between them. If that is raised to the power of a, notice that this is not a plus. Oh no, not a minus. Oh no, it's a multiplication. This only works for multiplications. This is x to the a times y to the a. That's what it is. Quick example. For example, if you have xy to the power of 2/3, then this is x to the 2/3 times y to the 2/3. That's what it is. So you see that the power a here was actually distributed, that's the word distributed, to both variables. Does that hold true if you have three variables? Yes, as long as they're multiplied. No problema. What about a division? If this is a division instead of a multiplication, Does the same type of rule hold? Seguro, of course, yes. That's x to the a divided by y to the a. Quick example. Suppose that we are given x over y to the power of, say, 5. Then this power 5 shall be distributed to both guys. Only true, only works if you have a division. So that shall be x to the 5 divided by y to the 5. Yo, ça va? Number 10, what do we got for you? Oh yeah, we'll mix some negative exponents with my division rule. So xy, if instead I have it to the power of a, I have it to the power of minus a. Oh well, the same type of thing actually applies. I'll write it as y to the a over x to the a. What happens there? Negative exponent, remember from the previous whiteboard? Negative exponent, what it does? It flips the fraction upside down. So the negative exponent, the x was on top, the y was on the bottom. It actually goes the other way around. The y goes up and the x goes down. And then I apply, it's a combination of two rules. Then I apply the exponent that I distributes to both. And that's y to the a over x to the a. Quick example. Suppose you have x over y to the minus 2. Is there a way to write this differently using rules of exponents? Of course there is. Flip that guy, y over x, and then you can have a power of 2. And of course, by doing this rule here, I get y squared over x squared. Good. One last. If I have x to the minus a over y to the minus a. Well, why don't we put it b here so that we have a little variety. It doesn't have to be the same exponent. X to the minus a over y to the minus b. What is that? Can you take an educated guess? What is that? You got your x to the minus a up. It's got a negative exponent, so you know what? It's going to come down. And look at the y to the minus b, which is down. It's got a negative exponent as well. What's going to happen to it? It's going to go up. That's y to the b on top. So that's y to the b over x to the a. Quick example. Suppose you have x to the minus 3 over y to the minus 4. What is that equal to? The x to the minus 3, the x to the minus a goes down as x to the a, so that will go down as x to the 3, but down instead of up. And the down was going to go up. The y to the minus 4 is going to be a y to the positive 4 on top. That's a 4 here. Looks like it's some sort of an alien symbol, x to the 4. So all in all, that's pretty much the picture of it. So basically, I'd like to just do a couple of examples with you. And clearly, what we're going to do when we meet in class later on this week is we're going to work on much more exercises than just a few ones we're going to be doing together today. All right. So let us see if we can select from the textbook a couple of examples that would turn out to be interesting. So I have here something like, so example 1. Example 1. Simplify. You're going to get used to my weird writing pretty soon. So simplify the following expression. X, y to the 3 multiplied by 3x squared y to the power of 2. We want to simplify this as much as possible. So what would we do? What would we do? What do you think is the first thing here that we have to take care of? If you're thinking, let's take care of the exponent here, You're absolutely correct. Okay, so what is this going to be equal to? I'm not going to deal with this for now. I'm going to leave it as such. And like we said, we're going to take care of that exponent too. What rule should I use for this? Well, of course, if you allow me a little bit of a change of color here, the rule that I want to use, the one that I want you to remember for this example, is this one, x times y to the power of a. This is a multiplication, of course. So what is that rule? This is x to the a multiplied by y to the a. Yes? Okay, so that means that I'm going to take my exponent 2, and I only have not 2 but 3 terms. So that's going to be 3 to the 2, and then x squared to the 2, and then y to the 2. It's like I'm using this rule, but instead of having 2 terms, I have 3. All right, so what is all this? This is x, y, 3, we can leave the bracket for now, times 3 squared, that's 9. X squared squared, c'est quoi la règle? What's the rule for this? X squared squared, well, x to the a to the b. Remember that rule, right? This is x to d. What do I do when I have exponents that are next to each other like this? I multiply them together. This is x to the a times b, baby. So that's going to be 2 times 2, baby. So that's going to be x to the 4. And y squared is y squared. Good. So now I can remove all the brackets and see if I can actually do some last simplification. I only have one constant, it's 9. It's customary to bring it to the front of the expression. So bring the 9 in front and let us remove tutte les braquettes. All of them brackets, they're gone. So this is x, y, 3, x, 4, y, 2. So now I'm looking for what is called like terms. In French, les termes semblables. What are the like terms? The like terms, they are, here I got an x to the 1, and here I got an x to the 4. So if I want, that's kind of an extra step that you don't have to come up to, but I'll do it just for the sake of the argument. I got x times x to the 4. I can bring them together, just like I can bring together y3 and y squared, which are the other like terms that are here, y3 and y squared. All right, so now what rule do I apply? This is x to the a times x to the b. This is this rule right here. X to the a times x to the b. What is that rule we saw? X to the a plus b. We're going to do this not once but twice. This is x to the 1 plus 4 multiplied by y to the 3 plus 2. Final answer, which is what I want to box, because I am done, is 9x5 y5. So this expression here boils down to that. We're going to revisit this in pre-cal. Pourquoi? Because this is super essential to actually advanced when we study calculus next semester. All right, so that's a relatively simple example. My markers want to get away from me. I will not let them. I need them to continue this lecture. All right. El segundo ejemplo. Example 2. What do I have for you guys here? Always picking this from the textbook. What about something like this? 3x cubed. So always the same thing, simplify. Simplify what? 3y to the minus 2 over what? 2xy to the minus 5. All of this, one is divided by the other, and this is raised to the power of minus 2. All right, this is a classic problem of a good level. Makes us practice plenty of rules, yes? So, what shall we do first? What shall we do first? What do you think? Deal with the inside of the bracket and then deal with the outside exponent? That probably would be a good strategy. So let us save that exponent outside negative 2 for later. Let's see what we can do within the bracket. Can I cancel 3 and 2? Nah. So that's going to be 3 over 2. What about x3 on top and x1 downstairs? What's the rule here? X to the a over x to the b. Yes, what is that? That is x to the a minus b. Seguro. So that's exactly what I am going to do. I'm going to say that's x to the 3 over x to the 1 is x to the 3 minus 1. I'll do the exact same thing for the y's. So y minus 2 minus 5. And that's already a major simplification over the original problem. Le problème. 3 over 2. That's going to be x to the 2 because 3 minus 1, yes. And what's this guy? Minus 2 minus 5. That's minus 2 plus 5. That would be what? 3. And the inside of the bracket has been completely simplified. Yay! All right, now it's time to take care of the outside exponent negative 2. Okay, what's the rule for this? What is the rule for this? So x, y to the a. What do when I have a multiplication of 2 or 3 terms in that case? Yes, that's going to be x to the a times y to the a, y at times, because there is a times here between x and y. Okay, so what's going on? 3 over 2 gets the power minus 2. x2 gets the power minus 2. y3 gets the power minus 2, in agreement with that rule that says just give the power to all the terms, and I can do that, remember, when there are multiplications in between my terms. D'accord. Okay, wow, what is this? X over y to the power minus a. X over y to the power minus a. Remember this one? What is that? So the negative exponent makes the fraction flip. So the x, which was affected by the minus a, goes down. The y that was down goes up. Why? Because of the negative exponent. That's our rule. So that means that this is now 2 over 3. Look at the 3 up goes down. The 2 down goes up. And now the power is just 2. Good. What other rule am I using here for the x to the 2 to the power of minus 2? I shall say this is x to the a to the b, bien sûr. And that's x to the a times b, baby. So that's going to be x to the 2 times minus 2. That's minus 4. And y to the power of 3 to the power of minus 2, I'm going to multiply them as well. Good. Now, we could leave the answer like this. It's not bad at all. But we are actually going to simplify this one more step because as a ground rule in calculus, it is better because it is simpler if we do not leave negative exponents in our answer. So one extra step, which would take me to my final answer, which I'm going to box, would actually be to do something like this. That would be 2 to the 2, 4, 3 to the 2, so 9. x to the minus 4. Remember that rule? X to the minus 4. So x to the minus a, what is that? We said 1 over x to the a. So that's going to be 1 over x to the 4. And look at the same thing here, y to the minus 6. So that's 1 over y to the 6. Good. This is a better answer. We could make it just a tad better if we bring all the fractions together, right? So that's the same as 4 times 1 times 1 over 9 times x4 times y6. And now, here we go for the true final answer. Now, it cannot be simplified beyond that expression. This would be 4 divided by 9x4 y6. This is as simplified as it will get. Good? Good. Okay, so if you have any questions on this, of course, you can ask when we meet later on this week. I want to do at least another example of this, maybe 2 if I have time. I don't want those videos to be too long. So one more example will be, what shall we do? What shall we do? Oh yeah, we could do stuff like this. So example 3. Let's use some numbers. So simplify, it's always simplify. So let's stray away from the x's and the y's for 1 second. Let's put in some numbers. So these guys are saying, what are they saying? What are they saying? They're saying 25 to the minus 1/2. 25 to the power of minus 1/2 minus 16 to the power of minus 1/4. All right. Okay. No x's, no y's. So we're not expecting an algebraic answer. We're expecting, clearly, what? A numerical answer, of course. Negative exponents, not a big fan. So once again, I'm going to use my rule that actually says x to the minus a is 1 over x to the a. And I will apply this not once, but twice. So 25 to the minus 1/2, same thing, mentions as 25 to the 1/2. Minus 1 over, that's going to be 16. And then the minus 1/4 downstairs becomes a positive 1/4. All right. Now, of course, I can punch these numbers in my calculator, but that is so not elegant. We can try to understand better what the calculator does for you if we simply remember what? That 25, I can write in another way. What is 25? You know 25. 25 is a perfect square. What is 25 the square of? 5, you're right. 5 squared. Yes, 25 is 5 squared. And I want to pull a similar stunt on 16. 16, I know 16. 16 is 4 squared. But 4 is 2 squared. Maybe I can write 16 as a power of 2. 2 to what power is 16? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 2 to the 4. Oh, very nice. Very, very, very nice. Very, 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 very nice. And here comes the rule of x to the a to the b. That is x to the ab, of course. So that's going to be 1 over 5 to the, this is my a, this is my b. So 2 times 1/2. 2 times 1/2. And that is 4 times 1/4. And of course, that is 1 over 5 to the 1, right? 2 times a half is 2 halves, is 1. And 4 times a quarter is also 1. So, yo, look at this. This is 2 to the 1. So it's 1/5 minus 1/2. If you want, you can do this calculator, or you can bring it to a common denominator. That'll give you 2 minus 5. La respuesta final, the final answer, minus 3 over 10. Good. So that's some elementary examples that we can actually use to practice our basic rules. We'll do some more in class, and we'll work in teams also in similar problems in class. That's the end of our first video. I hope it wasn't too much. I hope it was enough. I hope you're still there. I hope you'll be there next time. I hope to see you in class. I hope for a lot of things. Enough.